In this class, we are going to learn how to conduct and interpret the statistical analysis of high-dimensional data. We will also learn how to make our data analysis reproducible. By reproducible, I mean that for anyone given the same data, the analysis can be reproduced to give the same result. That may sound obvious and silly that I would emphasize this, but in working with large data sets, the number of opportunities for data to become mishandled increases, and the more analysis decisions get made that we want to document. Both data manipulation and analysis decisions can be difficult to recall later after we are done if we do not keep a complete record of our work. To help us, we want software with the following properties. We want it to be open source. This is for transparency of the methods, easily shared, and organized with version control. Version control allows us to store different versions of the same software in an organized system. Software that meets these requirements will allow us to create what we call reproducible research. Here are the tools we will use to do this. R is the open source environment and statistical language. Bioconductor is a project focused on software development for high-throughput genomic data. This is the type of data I will be using in this class. RStudio provides more tools for developing and sharing our software. Together, these tools make it easy to share code and create reproducible reports. Because of this, they are widely used in research. When developing code, we often have more than one version saved on our computer. This is because we have our clean version of our finished product, but then we may also want to go back and make a change and further develop the code. What we would like is a system to organize our files that allows us to share a clean version with others, but also to still work on the code while maintaining the ability to merge any changes we make back into the clean version. Git and GitHub allow us to do this. GitHub will store your files in the cloud where they can be openly shared. Anyone can make a copy of your code by cloning it to their local machine and using it. The code I will be using for this class will be available via GitHub for you to clone and run on your local machine. Git is the engine that manages the files and copies. With this tool, you can freeze a copy of the code for general distribution while continuing to work on a developmental version of the same code. And you will have the ability to fold any changes you make back into the original code. All of this can be done seamlessly through Git. Git will be the interface between RStudio, the work environment on your computer, and GitHub, which will store the code for class. Now you know how to handle how these different tools will help us throughout the term. You will also become familiar, or at least acquainted, with the tools commonly used by software developers. Please follow the instructions provided to install these programs on your computer.